Fusion Mobile, quality e-learning experience on the go.
Okay, you're welcome. This is Fusion Mobile e-learning platform, a solution center on the go. I remember my own self, I'm Oshito Gumolajide, aka Smoking Brain, and as you all know, I happen to be your biology tutor for today. And we will be looking at animal nutrition under biology. And the outlines for today are actually what is animal nutrition and everything you need to know under animal nutrition, food test, and lastly, we'll be looking at enzymes, the types of enzymes, the characteristics of enzymes, and everything you need to know basically on enzymes. So what is animal nutrition? What is animal nutrition? Now, to a layman, animal nutrition simply is the kind of nutrition carried out by animals. The kind of nutrition carried out by plants is called plant nutrition. The kind of nutrition carried out by animal is called animal nutrition. Now, animal nutrition is basically the mode of feeding of living organisms. Now, what kind of living organisms are we talking about? We're talking about animals specifically. Animals specifically. Now, animal nutrition is also known as heterotrophic mode of nutrition. Animal nutrition is also known as heterotrophic mode of nutrition. The word hetero talks about an organism depending on another organism for food. The word hetero talks about an organism lacking the ability to provide food by itself. The word hetero talks about an organism depending directly or indirectly on other organisms for food. Now, what other organisms do animals depend on for food? The answer is not far-fetched. It is basically plants. Now, plants are the primary producer in nature. Animals are consumers in nature. Again, plants are the primary producers in nature. Animals are consumers in nature. I take it again. Animal nutrition is basically known as an heterotrophic mode of nutrition. It's a kind of nutrition where organisms tend to depend on plants for food directly or indirectly. It is also known as holozoic type of nutrition. It is also known as a holozoic type of nutrition. And now we'll basically be looking at the types of feeding habits in living organisms. On that note, we would be having okay, so we've got on the board herbivores, carnivores, omnivores, frugivores, granivores, and lastly scavengers. What are herbivores? What are herbivores? Herbivores are plant-eating organisms. Herbivores are organisms that feed on plants. Herbivores are plant-eating organisms or organisms that feed on plants. Examples of herbivores are goats, cattle, etc. Now, what are carnivores? What are carnivores? Carnivores are flesh-eating organisms. Organisms that feed on flesh. A very good example it's the lion and your dog. Now, what are omnivores? Omnivores are organisms that feed on both plants and animal. They feed on both herbs and flesh. They feed on both plants and flesh. The example of omnivore is man. Man is an omnivore. Now, what are frugivores? Frugivores, granivores are special types of feeding habits. Now, frugivores are organisms that specifically feed on fruits. Frugivores are organisms that specifically feed on fruits. A very good example of your frugivore, it's your monkey. They specifically feed on fruits. Now, we have granivores as well. Granivores are organisms that specifically feed on grains. And lastly, we have got scavengers. Scavengers are organisms that feed on dead animals. They feed on dead animals, scavengers. A very good example of the scavenger is the vulture. So I will quickly take it again. So I said from the beginning that animal nutrition is a kind of nutrition carried out by animals. It is also known as an heterotrophic mode of nutrition. It could also be called a holozoic type of nutrition. And now we will be taking a look at the feeding habit. I said we've got the herbivores, the carnivores, omnivores, frugivores, granivores, and the scavengers. Herbivores are plant-eating organisms. A very good example is the goat. Carnivores are flesh-eating organisms. A very good example is the lion. Omnivores are organisms that feed on both plant and animal, both plant and flesh, both herbs and flesh. A very good example is man. Man is an omnivore. You and I happens to be an omnivore. And we have our frugivores as well, organisms that specifically feed on fruits. We've got our granivores, organisms that specifically feed on grains. And lastly, we've got scavengers. These are organisms that feed on dead animals. And a very good example is our vulture. So having established this fact, we would now be looking at feeding association among organisms. Feeding association among organisms. Feeding association among organisms. So the first on our list is parasitism. Parasitism. Now what is parasitism? Parasitism is basically a feeding relationship between two organisms. One is called the parasite, while the other is called the host. So whenever we're talking about parasitism, we're talking about parasite versus host. Parasite versus host. Now the host here happens to be a living organism as well. The parasite versus host. Now what happens with this kind of feeding association? What will be the end result? Who is benefiting and who is suffering? And we will be looking at it critically. Now the parasite benefits. The host suffers. To what extent is the suffering of the host? The host may die, or the host might just be harmed. So parasitism in all totality is a feeding association between an organism and another organism. The other organism is called the host. The parasite feeds on the host. The parasite lives in or on the host. The parasite lives in or on the host. When the parasite lives in the host, it is called endoparasite. When the parasite lives in the host, it's called endoparasite. When the parasite lives on the host, it is called ectoparasite. It is called ectoparasite. So I take it again. Parasitism is a feeding association between an organism called the parasite and another organism called the host. And the parasite lives in or on the host. The parasite benefits while the host suffers. The host might even die based on the severity of the harmfulness. So basically speaking, when parasites live in the host, they are called endoparasites. When they live on the host, they are called ectoparasites. Examples of parasites that live in the host. A very good example is your tapeworm. Tapeworm, roundworm, etc. A very good example of your ectoparasite is fleas, lice, bugs, it's like your bed bugs, etc. So mathematically, what do you think parasitism will be? And now we'll be able to establish the fact that parasites feed on the host. The parasites benefits while the host suffers, and at times the host might die. So basically speaking, parasites will be plus minus. The parasite benefits while the host suffers. The parasite benefits while the host suffers. Now, aside from parasites being classified as ectoparasite and endoparasite, they could as well be classified as what? Complete parasite and partial parasite. They could as well be classified as what? Complete parasite or what? Partial parasite. Now, complete parasite are a parasite that lives or depends totally on the host. They depend totally on the host. They are usually associated completely with the host. Now, on that note, they would lead to the death of the host. Partial parasites are parasites that depend partially on the host. So they could as well get their food from other sources. Again, complete parasites are parasites that are constantly found to be associated with a particular host. What will be the end result? They end up killing that host because everything they need, they get it from that host. There is no other alternative to survival except that host. Now, partial parasites are parasites that depend partially on a particular host for food. So when food is not coming from that host, they could as well get it from another alternate route. So now we'll be able to establish the fact that parasitism talk about two organisms, the parasite and the host, where the parasite benefits, the host suffers, the host might die based on the severity of harmfulness. I will say parasites that live in the host are called endoparasites. Those that live on the host, on the surface of the host, they are called ectoparasites. Examples are the fleas, the lice, the bugs. Examples of endoparasites, those ones that live in the host, they are tapeworm, roundworm, intestinal bacteria, as the case may be. Bacteria found in the rumen of cattle and all that, etc. So complete parasites are those that depend totally on a particular host for food, and so they suck out the host and they devour the host at the end of the day. Partial parasites depend partially, and they could as well get their food from another alternate route. So we will be looking at another feeding association. So the second on our list is what we call commensalism. Commensalism. Commensalism is basically a feeding association between two organisms as well. And so this time around, it is the commensal versus another organism. Let's call the organism the host. The commensal versus the host. So what will happen to the commensal when it associates itself with the host? The commensal benefits. The commensal benefits. The host is unaffected. And so now we'll be looking at predation. Now predation stems from the word predator. So predation is a feeding association between two organisms, and one is called the predator, while the other is called the prey. So predator versus prey. Predator versus prey. Now the predator benefits, while the prey suffers. And most times the prey dies off. So most times the predator ends up killing the prey. A very good example is the relationship between lion and goat. Lion and goat. Lion would end up killing the goat. So mathematically, predation will be plus minus. Plus minus. Plus minus. The predator benefits while the other organism suffers. And now most times, the predator is usually the bigger organism and the stronger organism compared to the prey. The predator is usually small and weak. But there are exceptions to it, because there are some predators and they are very, very small in nature, but they end up doing greater things. And so it is also acceptable. But usually, predation is a relationship between two organisms, the predator and the prey. The predator benefits, the predator ends up killing the prey. The predator most times happens to be the stronger organisms, happens to be the bigger organism, while the prey happens to be the smaller organism or the weaker organism, as the case may be. So now we'll be looking at another feeding association, and this one is called, saprophytism. Saprophytism gets its root word from saprophyte. In saprophytism, organisms feed on dead organic matter. In saprophytism, organisms feed on dead remains of plant and animal. Usually the organism that carry out this kind of reaction is called the saprophyte. It's called the saprophyte. So saprophyte versus dead remains of organic matter or dead remains of plants and animals. So saprophytes are organisms that feed on dead remains of organic matter or dead remains of plant and animal. Now, how do they digest their food? They digest their food extracellularly. Now, what do I mean by extracellular? It means they digest their food on the outside, and they make use of enzymes. These enzymes are basically called exoenzymes. Exoenzymes. Now, examples of saprophyte are your mold, your mucor, etc. And so that's everything you need to know about saprophytism. Again, saprophytism is a feeding association between the saprophyte and dead remains of organic matter. The saprophyte decomposes dead remains of organic matter, they feed on it, and they do this extracellularly. They make use of enzymes, and these enzymes are called exoenzymes. Again, these enzymes are called exoenzymes. And so far so good, we've been able to look at parasitism, commensalism, predation. We looked at saprophytism, and now we're going to be looking at symbiosis or mutualism. So that will be the last one we'll be looking at. Symbiosis is also referred to as mutualism. For a particular feeding association or relationship to be mutual, it means both parties are actually bringing something to the table. It means both parties are benefiting. It means both parties are sharing things in common. Now, organisms that undergo symbiosis are referred to as symbionts. They are referred to as symbionts. Symbionts. A very good example of a symbiosis relationship is what we call the liking. The liking. The liking. And liking is a relationship or a feeding association between two organisms, the algae and the fungi. And now you and I know that fungi does not photosynthesize. Why? Because they lack chlorophyll. Algae does photosynthesize because it possesses chlorophyll. So here, algae brings the food to the table. Algae provides the food, while fungi brings protection to the table. So fungi gets to protect algae. Algae helps to feed the fungi. So that kind of relationship where both parties are bringing something, both parties are contributing for their individual well-being is called symbiosis. And the relationship between algae and fungi is referred to as what? Liking. It is referred to as what? Liking. So aside from liking, we also have another relationship. And that's what? Bacteria with the root nodules of plants. Bacteria, nitrogen fixing bacteria for the root nodules of plants. Nitrogen fixing bacteria with the root nodules of plants. Now this nitrogen fixing bacteria helps to fix nitrogen. It helps to fix nitrogen in the soil. The root nodules of plant in turn provides the bacteria with food, protection, and a place to stay. Okay, nitrogen fixing bacteria versus root nodules of plant. Now the nitrogen fixing bacteria specifically is Rhizobium leguminosarium. Rhizobium leguminosarium versus the root nodules of plant. It is always associated with the root nodules of plant. Now, nitrogen fixing bacteria helps to fix nitrogen in the soil. And the root nodules of plant in turn will provide food for the bacteria. It will protect the bacteria and it will provide a place for the bacteria to stay. And so now we've been able to establish the definition and facts concerning symbiosis, also known as mutualism, concerning commensalism, concerning parasitism, and concerning predation. So symbiosis mathematically is plus. Both are benefiting. So we say it is what? Plus. So now we've been able to look at so many things under animal nutrition. So far I said animal nutrition is also known as a heterotrophic type of nutrition or a holozoic type of nutrition. I said in heterotrophic type of nutrition, animals tend to depend directly or indirectly on plants for food. Animals that feed on herbs are called herbivores. Those that feed on flesh are called carnivores. Those that feed on both plants and flesh is referred to as omnivore. Frugivores are special animals that feed on fruits. And granivores are organisms that specifically feed on grains. Scavengers are organisms that feed on dead animals. A very good example is your vulture. And now we're able to look at symbiosis, commensalism, parasitism, saprophytism, and predation. So now we will be looking at food test. And before we get to food test, I would love us to quickly look at balanced diet, the classes of food, and food test, so to speak. So what is balanced diet? What is balanced diet? Now, right from our primary school days, we have been taught the definition of balanced diet. And funny enough, the definition remains the same. It happens to be unchanged with time. And so we're going to stick with the status quo. We're going to follow the trend so far. So balanced diet is a diet that contains all the classes of food in the right proportion. Balanced diet is a diet that contains all the classes of food in the right proportion. It is referred to as a meal. It is referred to as a meal, a diet that contains all the classes of food in the right proportion. So what are the classes of food? What are the classes of food? Number one, we've got carbohydrate. Carbohydrate, protein, fat and oil, mineral salts, water, and raw phages. Water and raw phages. Carbohydrate, protein, fat and oil, mineral salts, water and roughages. It is very, very important for you to note that of all the classes of food, ranging from carbohydrate, protein, fat and oil, mineral salt, water and roughages, are the one that gives the body the most needed energy. The one that gives the body the greatest amount of energy is fat and oil. It is not carbohydrate, it is fat and oil. Of all the classes of food, the ones that give the body the greatest amount of energy in terms of calories, in terms of number, in terms of availability is fat and oil. Fat and oil. So we'll be looking at carbohydrate, protein, fat and oil, mineral salts, water and roughages briefly. So what are carbohydrates? Carbohydrates are food that are rich in starch. Carbohydrates are starchy foods. They are foods that are rich in starch. Carbohydrate is basically divided into three. Carbohydrate is basically divided into three. We have the monosaccharide, and we have oligosaccharide, and we have polysaccharide. The word mono means one. The word oligo means few. The word poly means more, or we can simply say many. So again, I take it carbohydrate is basically divided into three. We have monosaccharide, we have oligosaccharide, and lastly we have polysaccharide. Now monosaccharide simply means one, oligosaccharide means few, while polysaccharide, poly means what? Many. So now what is monosaccharide? Monosaccharide it's a sugar that contains 6 carbon units. Monosaccharide is a sugar that contains 6 carbon units. Monosaccharide is a sugar that contains 6 carbon units. Oligosaccharide is also referred to as reducing sugar. It's referred to as reducing sugar. Polysaccharide is referred to as complex sugar. Monosaccharide is a sugar that contains 6 carbon units. A very good example of the monosaccharide is your glucose, fructose, and galactose. Galactose is not gotten from gala, please. Don't mix it up. So a very good example of your monosaccharide is your glucose, your fructose, and your galactose. Again, a very good example of your monosaccharide is your glucose, your fructose, and your galactose. And they all have 6 carbon sugar. 6 carbon sugar. So basically you can call them exose sugar. Exose sugar. 6 carbon sugar. They are glucose, fructose, and what? And galactose. Now the general formula for carbohydrate is C water N. C water N. This is the simplest formula for carbohydrate generally. So how do we get one for monosaccharide? You and I have been able to establish the fact that monosaccharide has 6 carbon units. So that means N is equals to what? 6. So let's remove this N and put 6 here. 6 times 6 is what? C6. 2 times 6, H12O6. So the formula for glucose, fructose, and galactose is C6, H12O6. Again, the formula for glucose, fructose, and galactose is C6, H12O6. Monosaccharide has 6 carbon sugar. They are exose sugar. They have 6 carbon units. A very good example is your glucose, fructose, and your galactose. Their general formula is C water N, and since N is 6, since they have 6 carbon sugar and since they are exose sugar, we'll say their general formula then should be C6, H12O6. C here signifies carbon, H signifies hydrogen, O signifies oxygen. So we'll be moving on to the next one, oligosaccharide. So now what are oligosaccharide? Oligosaccharide are generally known as reducing sugar. The word oligo, as I said earlier, means few. It means few. So now what are the groups or examples of oligosaccharide? They are called disaccharide, trisaccharide, among many others. Disaccharide. So we'll be taking disaccharide in this class today. Disaccharide. Disaccharide simply means that when you tend to combine 2 monosaccharide. Mono means one. When you combine 2 monosaccharide together, what we call disaccharide. Take note. Monosaccharide has 6 carbon units. So combining 2 monosaccharide will give you 12 carbon units. Disaccharide will give you 12 carbon unit there. And so you and I know that oligosaccharide is a reducing sugar. So disaccharide by extension is also a reducing sugar. However, they are gotten through the process of hydrolysis. Now, what do I mean by that? For you to get an oligosaccharide, a water molecule has to be lost. But before we get to that stage, I would love to give us everyday examples of disaccharide, which happens to be a group member of oligosaccharide. So how do we get disaccharide? We add two monosaccharides together. Glucose plus fructose. Glucose plus galactose. Glucose plus glucose. Glucose plus fructose is known as sucrose. So sucrose is a very good example of a disaccharide. Glucose plus galactose is known as lactose. So lactose is a very good oligosaccharide. By extension, a very good disaccharide. Glucose plus glucose is called maltose. It's called maltose. And so the examples are sucrose, lactose, and maltose. So sucrose, lactose, and maltose are disaccharide. And now let's quickly look at their general formula. Recall the general formula is seawater N. The general formula is seawater N. Let me bring it up. General formula is seawater N. And we know that N is equals to 12. And recall I said a water molecule has to be lost. So at the end of the day, we take away water. So C water 12. C 12. 2 times 12. H 24. O times 12. O 12. Now let's take away water from here. We take away 2 hydrogen from here. 2 hydrogen. So when we take away 2 hydrogen from here, we have C 12. H 22. When we take away 1 oxygen from here, we have O 11. So this is the formula for sucrose, lactose, and maltose. Again, this is the formula for sucrose, maltose, and lactose. Sucrose is glucose plus fructose. Maltose is glucose plus glucose. Glucose plus galactose will give you our lactose. It will give you our lactose. Sucrose is also known as cane sugar. You can get it from sugar cane. No, cane sugar. Sugar cane. Like you just need to turn it around. You need to just oppose it. So now we're done with carbohydrate. But one important thing on that carbohydrate that we need to know is the general importance of carbohydrate. Carbohydrate is actually a major source of the cell wall. And before we go, I would quickly like to talk about polysaccharide. Polysaccharide. Now, polysaccharides are generally known as complex sugar. They are known as complex sugar. They are a major component of the cell wall of plant. A very good example of polysaccharide are cellulose, gums, chitin, etc. Cellulose, gums, chitin are very good example of our polysaccharide. They are the major component of the cell wall of plant. They are generally known as complex sugar. Even your starch belongs to this group. The starch, the general starch that you and I get to know of, belongs to this group of polysaccharide. And so let's look at the importance of carbohydrate. That the major component of the cell wall of plants, they help in providing the body with what? With energy. And it is also pertinent to note that carbohydrate is stored in plants as starch. Carbohydrate is stored in plants as starch. How then is carbohydrate stored in animal? Carbohydrate is stored in animal as glycogen. Carbohydrate is stored in animal as glycogen. Carbohydrate is stored in starch, is stored in plant rather as starch. It is stored in animals as glycogen. So let's quickly take a look at protein. Protein. And now the major component of protein is what we call the amino acid. Amino acid is a major component of protein. When proteins are broken down, it will give us amino acid. Again, when proteins are broken down, it will give us amino acid. And so now a very good source of protein is your beans. And when you take your beans through your mouth, the beans goes down, you regurgitate, you do churning movement, you break down the beans. Basically, protein will first be broken down into peptones. From peptones, it will be broken down into polypeptides. Then from polypeptide, it will now be broken down into amino acid. So these are the process of digestion. You take your beans from the normal form of the protein, it will be broken down into peptones. From peptones, it will be broken down into polypeptides. Then from polypeptide, we will now have the what? The amino acid. From polypeptides, we will now have the what? The amino acid. So the smallest unit of protein is what? Amino acid. The functional unit of protein is what? Amino acid. You need to take note of this. And now lack of protein in the body will lead to a kind of, how do I call it, a kind of disease or a kind of situation or a kind of condition called kwashiorkor. A kind of condition called what? Kwashiorkor. Are you with me? Now, what are the advantages of protein? Before we do the advantages of protein, I would like to, how do I say it? I would like to give us an important information. Now, there are basically 20 amino acids in the body. There are basically 20 amino acids. They are divided into 10 and 10. We have 10 essential amino acids. 10 essential amino acids. And we have 10 non-essential amino acids. Now, what are essential amino acids? Essential amino acids are those amino acids needed by the body. But they have to be taken in. The body cannot produce them. They have to be taken in through the diet. Non-essential amino acids are those amino acids that the body can produce. So we will be just looking at examples of essential amino acids. Then after looking at that, we'll be looking at the advantages of protein. So the essential amino acid can be gotten through the use of this acronym. HALTTPVIM. HALLTTPVIM. HALTTPVIM. Now the H here stands for histidine. The H stands for histidine. The A stands for alanine. The L stands for leucine. The other L stands for, okay, let me try and remember. Histidine, alanine, leucine, lysine. And the T here stands for tryptophan. And the other T here stands for threonine or threonine, based on your pronunciation. And the P here is phenylalanine. The other V is valine. I is isoleucine. And the last one, M, is what we call methionine. Methionine is also very important for child development. So these are the 10 essential ones. HALTTPVIM. Histidine, alanine, leucine, lysine, tryptophan, threonine, phenylalanine, valine, isoleucine, and lastly what we call the methionine. So what are the advantages of the various importance of protein? Now protein helps in the repair of worn out tissues in the body. Protein helps in the build up of carbon skeleton. Protein helps protein helps in reactions. Protein helps in chemical degradation. So protein have great or immense importance in the body. So we will now be moving on to the third one. So the third is what we call fat and oil. Now fat and oil are generally called lipids. Fat and oil are generally called lipids. So what then are the differences between fat and oil? What is fat and what is oil? Now fat is solid at room temperature. Fat is solid at room temperature. What then is oil? Oil is liquid at room temperature. Fat is solid at room temperature. Oil is liquid at room temperature. Lipid is stored in plants in form of oil. Liquid is stored in plants in form of oil. Lipid is stored in plants. Is stored in plants as what? Oil. Lipid is stored in plants as oil. Lipid is stored in animals as fat. Lipid is stored in animals as fat. I take it again. Lipid is basically divided into two: fat and oil. Fat and oil are called lipid. Fat is stored in animals. So lipid form in animal is called fat. Lipid form in plant is called oil. Oil is liquid at room temperature. Fat is solid at room temperature. Examples of food that could actually give us fat and oil is our groundnut oil, your lard, your cheese, your butter, okay, etc. So we've been able to establish the definition of fat and oil. the major differences between fat and oil. And so we'll now look at the importances. I remember I said the chief source of energy in the body are the classes of food that gives the body the greatest amount of energy is fat and oil. It is not carbohydrate, it is fat and oil. Don't forget. And so now we'll be looking at the advantages of fat and oil. What are the advantages? They are the major component of the cell membrane. They help the body in carrying out rigorous function. As a matter of fact, most times when you see someone that has added weight, you say, the person is fat. So it means that the person has a lot of fat in the body. So fat by extension is even talking about fat and oil. So now we'll be looking at one major group called the vitamins. Now vitamins happen to be an interesting, very, very interesting. And so I need you to stay focused. I need you to stay concentrated. And so what are vitamins? Vitamins are, how do I define it? Now vitamins help in the digestion of food materials. They help in the easy digestion of food materials. They help in the easy breakdown of food materials. And now that we've been able to establish the definition of vitamins, we would now be looking at the types of vitamins. Vitamins are basically divided into two. Vitamins are basically divided into two. We have the fat-soluble vitamin. Fat-soluble vitamin. And we have the water-soluble vitamin. Now, what do I mean by fat-soluble? Fat-soluble simply means the vitamin can dissolve in fat. It means the vitamin is soluble in fat. It can dissolve. Solubility talks about the dissolving ability of a substance. And now, fat-soluble means it can dissolve in fat. Water-soluble means it can dissolve in water. So what are those fat-soluble vitamins that we have? We call them ADEC. ADEC. The fat-soluble vitamins are called ADEC. Vitamin A, vitamin D, vitamin E, and vitamin K. The water-soluble vitamins are called vitamin B complex and vitamin C. So we have vitamin B complex and vitamin C. And so we'll be looking at vitamin A, D, E, K briefly. We'll also be looking at vitamin B complex and vitamin C. Vitamin A is called retinol. I need you to pay attention. Vitamin A is called retinol. Now the word retina stems from the word retinol rather stems from the word retina. So that means it has a lot to do with the eyes. Vitamin A has a lot to do with the eyes. I don't know if you've ever come across someone that cries a lot, but whenever he's crying, you don't see tears in his eyes. And it's as if he's trying to like fake it up. And now that happens because vitamin A is deficient. Now when you see somebody that cries a lot and there are no tears on his face, it means the person is suffering from xerophthalmia. Xerophthalmia simply means dry eyes. It is caused by the deficiency of vitamin A. Lack of vitamin A in the body or limited amount of vitamin A in the body will cause what we call xerophthalmia. Now, aside from xerophthalmia, deficiency of vitamin A could also cause other eye defects or other eye diseases. And now, don't forget, vitamin A is called what? Retinol. Retinol. It has a lot to do with the eyes. It has a lot to do with the eyes, the retina. Retinol. So now, let's move on to the next one, vitamin D. Vitamin D is called calciferol. Vitamin D is called calciferol. Now, whenever you hear the word calciferol, what must readily register in your mind is the word calcium. Vitamin D, calciferol, calcium. And thank God for that long time advertisement where I think I could see, remember, a guy will come out and say vitamin D for strong bones. So we're still going to major on that. So basically vitamin D is meant for what? Bone formation, strong bones, everything that has to do with bone. So vitamin D is called calciferol. It helps in the hardening of bones. Hardening of bones is called ossification. Now, the deficiency of vitamin D will lead to softening of bones. Vitamin D generally helps in the hardening of bones. So deficiency of it, limited amount of it, will cause what we call, will lead to what we call. So deficiency of vitamin D will lead to what we call softening of bones. Softening of bones. And softening of bones is generally called osteoporosis. Osteoporosis. Now, osteology is study of bones. So whenever you see osteo, it means we're talking about bones. So osteoporosis means the bone is porous. And porosity of the bone will lead to the softening of the bones. Softening of the bones. And now you've seen people, while they are growing up, or even people that have grown up, you see most of them, they have bow leg. Bow leg. So bow leg is actually a local name. It's like a local parlance. So strictly speaking, a bow leg is called ricket. So vitamin D also causes ricket. Vitamin D leads to what we call ricket. So deficiency of vitamin D will cause rickets. Deficiency of vitamin D will cause osteoporosis. So vitamin D generally helps in strong bone formation, helps in strong gum, and every other thing that has to do with bones, basically. And so now we'll be looking at vitamin E. Okay, so vitamin E is called tocopherol or anti-sterility vitamin. And the word sterility talks about somebody being sterile. It talks about someone being called impotent. And so anti-sterility means it is against that fact. It is against sterility. It is against impotency. And so the major function of vitamin E is to keep the functionality of a man in check. The man in you must continue to function. Basically, that's what I'm saying. And so vitamin E is actually recommended for every man out there. You can take vitamin E as a supplement. It is actually good. And there are fruits you take that help to boost the flow of urine in the penis and all that. A very good example is your pawpaw. And most times you tend to see those married men every day. They'll be taking garden egg and granules. And you're like, why are they taking it? So this is actually one of the secret steps to, I know you understand what I'm saying. So basically we call vitamin E tocopherol or anti-sterility vitamin. And so they help in the excessive flow of blood to the penis and all that, every other thing that has to do with reproduction and every other thing. So tocopherol or anti-sterility vitamin, they make sure that man is kept in check, man is functioning, and the woman is functioning as well. And so lack of vitamin in the body will cause sterility. It could lead to impotency. And so we're done with vitamin E. And so we'll be looking at, we'll be looking at the last one, and that's vitamin K. Recall, we're looking at fat-soluble vitamin, ADEK, ADEK. We're done with vitamin A, retinol, calciferol, tocopherol. The last one, vitamin K, is called phylloquinone. Phylloquinone. We call it phylloquinone or anti-hemorrhagic vitamin. It means it's a kind of vitamin that helps in blood clotting. It is against anything that would serve as an obstacle to blood clotting. So whenever you have an injury, sort of vitamin K will get to work. Its work is to help you to recover quickly. And so whatever will stand on the way that would not make you recover quickly, vitamin K tends to fight them. And so vitamin K is called phylloquinone or anti-hemorrhagic vitamin. A very good source of vitamin K is our vegetable. It helps in blood clotting. It helps in blood clotting. The word hemorrhage is a stem word or the root word for hemorrhagic. It simply means bleeding, uncontrolled bleeding, excessive bleeding. And so the work of vitamin K is to work against that. The work of vitamin K is to clot your blood on time. And now there is an enzyme that is responsible for blood clotting, and we call it thromboplastin or thrombokinase. Thromboplastin or thrombokinase. And so now let's quickly take a look at vitamin K again. It is called phylloquinone or anti-hemorrhagic vitamin. It helps in blood clotting. Whatever tends to function against blood clotting, it fights against it. A very good source is the vegetable. It is, the enzyme responsible for blood clotting is called thromboplastin or the thrombokinase. So now we'll be looking at the water-soluble vitamin. We're done with the fat-soluble vitamin, retinol, calciferol, tocopherol, phylloquinone. So we're now going to be looking at the water-soluble vitamin, which is vitamin B complex and vitamin C. Vitamin B complex. Now the vitamin B complex are divided into many forms, and we'll be looking at them. We have vitamin B1, we have B2, we have B3, we have B5, we have B6, we have B12. And so vitamin B1 is called thiamine. It's called thiamine. Vitamin B2 is called riboflavin. Vitamin B3 is called niacin or nicotinamide. Vitamin B5 is called pantothenic acid. Vitamin B6 is called pyridoxine. While vitamin B12 is called cyanocobalamin. Okay, so these are the vitamin B complexes that we have. Vitamin B1 is called thiamine. Vitamin B2 is called riboflavin. Vitamin B3 is called niacin. Vitamin B5 is called pantothenic acid. Vitamin B6 is called pyridosine. Vitamin B12 is called cyanocobalamin. So I would only major on vitamin B1. So lack of vitamin B1 will cause what we call pellagra. Pellagra, like rough skin, pellagra. Will cause what we call pellagra. And so now I will quickly recap the various types of vitamin B complexes that we have. Vitamin B1 is called thiamine. Vitamin B2 is called riboflavin. B3 is called niacin or nicotinamide. B5 is called pantothenic acid. B6 is called pyridosine. B12 is called cyanocobalamin. Cyanocobalamin. So now we'll be looking at the last one, which is vitamin C. Vitamin C. Vitamin C. Vitamin C is called ascorbic acid. Vitamin C is called ascorbic acid. So lack of vitamin C in the body or deficiency of vitamin C will cause what we call scurvy. Scurvy simply means bleeding gum. Your gum is bleeding, scurvy. So you could actually take vitamin C as supplement. It will help relieve you from a weak gum and everything that has to do with gum. So vitamin C is called ascorbic acid. Scurvy, a very good source of it is your orange. You can get vitamin C from your orange as well. So now we will be moving straight into the topic called food test. We'll be able to establish the various types of food substances that we have. We've looked at carbohydrate, we've looked at protein, we've looked at fat and oil, we've looked at vitamin. Okay, so let's quickly take a look at mineral salts, just lightly. So minerals are needed in the body. They function as cofactors. They function as enzyme activator. They function as cell wall formation. So what are these minerals? Mineral salts. So basically the mineral salts are phosphorus, calcium, nitrogen, oxygen, etc. Now these ones are called major elements. We call them major elements. Cobalt, molybdenum, zinc, chlorine are called minor or trace elements. So we call them minor or trace elements. So let's take a look at next one, roughages. Now what are roughages? Now roughages are food substances. Their major constituent is fiber. They are food substances that help in fighting against constipation. They help in easy digestion. And most times when we tend to have constipations, we don't take vegetables or food that are rich in vegetables. So roughages simply means you're getting the fibers from carbohydrates, protein. Basically you're mixing up 2 or 3 food substances, and when you take it, you will get free. It helps to free the bowel. Free the bowel. So the bowel can now empty themselves. So we call them roughages. So quickly, the last is water. Water is a universal solvent. Water is H2O. That's the chemical formula for water. It combines 2 to 1. That is the volume of combination. Water helps in digesting food substances. The purest form of water, the purest form of natural water, so to speak, is rainwater. Other sources of water are spring water, stream water, river water. Water boils at 100 degrees Celsius. Water freezes at 0 degrees Celsius. Water experiences anomalous expansion at 4 degrees Celsius. So I think those are things you need to know on the water. So food test. How do we test for carbohydrate? How do we test for carbohydrate? Now you test for carbohydrate by adding a solvent called iodine or iodine. Now when you get probably a raw yam, the one you bought for the market, uncooked one, and you pour iodine on it, and you happen to notice a blue-black correlation, a blue-black coloration. You happen to notice a blue-black coloration, then we say starch is present. Starch is present. So that's the test for carbohydrate. Now what's test for protein? There are basically, I think, 3 types of tests. We have the million reagents. We have the million reagents. We have the Burette test. Burette test. And we have the xanthoproteic test. Xanthoproteic test. And now what are the tests? Now for this test, there's actually a change in color. So when there's a change in color from the normal one, you tend to know. There are specific colors anyway. So aside from protein, we have reducing sugar. Reducing sugar. So the test for reducing sugar is Fehlin solution. Fehlin solution and Benedict solution. So what's test for simple sugar? Simple sugar and monosaccharide. The test for simple sugar is just Benedict solution. And so now what is the test for fat and oil? Fat and oil has got two tests, two different tests, so to speak. We have a Sudan 3 test, and we have the translucent test. For the translucent oil, you pick for the translucent test rather. You pick a small volume of oil, you drop it on a particular material, and if it allows light to pass through it, it shows that that particular drop that was on top of the material happens to belong to the group of fat and oil. It shows that of the truth that that particular solvent is fat and oil. And so fat and oil is Sudan 3 test and translucent test. And so the last one now is a test for water. Now how do you test for water? You make use of blue cobalt chloride paper. Now when you dip it into an unknown solvent, it turns to pink, from blue to pink. And so if truly it changes from blue to pink, then that unknown solvent is called water. Oh man, so carbohydrate blue-black test shows that carbohydrate is present. Million reagent, burette test, anthropotheric test is actually a test for protein. Felic solution, Benedict solution is a test for reducing sugar. Benedict solution is strictly a test for simple sugar. Sudan 3 test, translucent test is a test for fat and oil. Blue cobalt chloride paper, when you dip into a solution and it turns pink, shows that water is present. So now we'll be looking at enzymes, and that will be the last outline for today. So now what are enzymes? Enzymes are organic catalysts that speed up the rate of chemical reaction. Enzymes are organic catalysts that slows down the rate of chemical reaction, but yet remain unchanged at the end of the reaction. And so we can say, instead of us making this definition cumbersome, we can try as possible to make it simple or simplified as the case may be. And so we would not say that enzymes are organic catalysts or enzymes are biochemical catalysts that alters. So instead of us saying speed up or slow down, it will be that alters the rate of chemical reaction, but yet remain unchanged at the end of the reaction. To alter simply means to promote or to try to reduce, sort of. So enzymes are organic catalysts that alters the rate of chemical reaction, but yet remain unchanged at the end of the reaction. So at the end of the reaction, you tend to see enzymes the way they were when they started the reaction, or the way they were when they joined the reaction. And so now, what are the characteristics of enzymes? Enzymes are proteinous in nature. Enzymes work best at 37 degrees Celsius. Now 37 degrees Celsius is the normal human body temperature, so it is optimum for them. And so we said that enzymes are proteinous in nature. Enzymes work best at 37 degrees Celsius. Enzymes are specific in nature. Now these days, you most times when you happen to send somebody on an errand, instead of that person to go straight, it probably might branch somebody's house, sort of. And so that person is not specific in nature. He's not carrying out the task as urgent as it is. So basically, enzymes are specific in nature. They go straight to the point. They are not the type that will branch somebody's house. They catalyze the reaction. They are specific in nature. And so we say enzymes are proteinous in nature. Enzymes are specific in nature at 37 degrees Celsius. Enzymes act on substrate. The substances enzymes act upon are called substrate. So enzymes act on what? Substrate. So we need to establish the fact that enzymes are proteinous in nature. Enzymes work best at 37 degrees Celsius. Enzymes are specific in nature. Enzymes act on substrate. Okay, now the characteristics of enzymes are they are proteinous in nature and they work best at 37 degrees Celsius. They are specific in nature. They act on substrate. They are needed in small quantities. They retain their chemical composition. At the end. They catalyze reversible reaction. Okay, so enzymes are proteinous in nature. They work best at 37 degrees Celsius. They are specific in nature. they act on substrate, they are needed in small quantities. They retain their chemical composition at the end of the reaction. That means they remain unchanged. And they catalyze reversible reaction. For the last time, they are proteinous in nature. They work best at 37 degrees Celsius. They are specific in nature. They act on substrate. They are needed in small quantity. They retain their chemical composition at the end, and they catalyze a reversible reaction. So now we're going to be looking at the types of enzymes and the classes of enzymes. Now, enzymes are basically divided into two. We have the intracellular enzymes and we have extracellular enzymes. Now, intracellular enzymes are enzymes that function inside the cell. They function inside the cell. Now, examples are enzymes that are found in the mitochondria. The mitochondria of plant and animal is generally known as the powerhouse. Now, they don't have generator here. Powerhouse, power. But it doesn't have to do with electricity, but it has to do with production of energy, oxidation of food molecules. And so that's how we call mitochondria the powerhouse. So examples of those enzymes are like your ATPase. ATPase is actually an intracellular enzyme. It's found inside the cell. Examples a very good example is the ATPase. It's found in the mitochondria. Now, extracellular enzymes are enzymes that function outside the cell, not outside the body. Outside the cell, in the body. Now, a very good example of the extracellular enzymes are the digestive enzymes. The digestive enzymes. Extracellular enzymes are digestive enzymes. They function outside the cell. They function outside the cell. Intracellular enzymes function inside the cell. Examples are enzymes that are found in the mitochondria, the ATPase. Extracellular enzymes function outside the cell. Examples are the digestive enzymes. And so now we'll be looking at the classes of enzymes. Classes of enzymes. Hydrolysis, oxidoreductases, isomerases, ligases, lyases, and lipases. Hydrolysis, oxidoreductases, lyases. Okay, the last one is transferases. Classes of enzymes. Hydrolysis. Now, hydrolysis are enzymes that help in carrying out reactions that has to do with hydrolysis. Any reaction that has to do with water, basically, we call it hydrolysis. Oxidoreductases are enzymes that help in oxidation reaction and reduction reaction. Isomerases are enzymes that help to catalyze isomeric reactions. What is an isomer? An isomer it's a compound or an element having the same molecular formula but different structural formula. So those reactions that has to do with isomers, isomerases does that. Ligases, they help in breaking down bonds as well as lyases. While transferases helps in changing the positioning, so to speak, of enzymes. Just like if you have A plus B, it's got C plus D. Now it can just be changed to like A plus B, it's got to D plus C. Like you're interchanging it, so to speak. Transferase, like you're transferring. So these are the classes of enzymes: hydrolysis, oxidoreductases, isomerases, ligases, lyases, and lastly transferases. Now there's something that we need to note here. All digestive enzymes are hydrolysis. All digestive enzymes are hydrolysis. All digestive enzymes belongs to the group hydrolysis. Again, all digestive enzymes belong to the group hydrolysis. So now, lastly, we're going to be looking at digestive enzymes. We're going to be looking at their source. We're going to be looking at their location. We're going to be looking at the substrate they act upon. And we're going to be looking at the end result of their action upon that substrate. Okay, so here on the board, it's a table showing the various types of enzymes digestive enzymes specifically, their sources, their locations, the substrates they act upon, and the end result or the effect of their actions upon those substrates. So we have the common enzyme. One of the notable enzymes that most people are familiar with is thiolin. Thiolin. Now, thiolin is found in the mouth. The mouth is the location. The mouth is the location of the thiolin, but the source is the salivary gland. The source is the salivary gland, but the mouth is the location. It acts on starch. It acts on starch, carbohydrates, starchy food, and basically the end result is that it digests starch partially to maltose. It digests starch partially to maltose. And so in the stomach, we have two notable enzymes. They are called renin and pepsin. They are called renin and pepsin. They are found in the stomach. Both act on protein. Both act on what? Protein. Their source is the gastric gland. Renin and pepsin are found in the stomach. Both of them, they act on protein. Their source is the gastric gland. When renin acts on protein, it helps in the curdling of milk. And whenever you hear the word milk, the enzyme that most readily register in your mind is renin. And now when pepsin acts on protein, they would give us peptones. When pepsin acts on protein, they will give us what? Peptones. And so now in the duodenum, very close to the stomach, we have three notable enzymes. We have the pancreatic lipase, we have the amylase, and we have the trypsin. In the duodenum, we have three notable enzymes. We have the pancreatic lipase, we have the trypsin, and we have the amylase. And now the pancreatic lipase acts on fat and oil to give us fatty acid and glycerol. Amylase acts on starch to give us maltose, while trypsin acts on protein and peptones to give us peptones and polypeptides. I take it again. In the duodenum, we have three notable enzymes. We have the pancreatic lipase, we have the amylase, and we have the trypsin. The pancreatic lipase acts on fat and oil to give us what we call fatty acid and glycerol. Take note, the pancreas is the source. The pancreas is the source. The pancreas is the source. And now when amylase acts on starch to give us maltose, and while trypsin acts on peptones, act on proteins and peptones to give us peptones and what? Polypeptides. So lastly, in the small intestine, we have some groups of enzymes whose sources is known as the succus entericus. The source is known as what? The succus entericus. It is found, it is the source of erepsin, lipase, maltase, sucrase, and lactase. And they are all located in the small intestine. So now let's look at the substrate they act upon and their end result. Now erepsin act on polypeptides and they give us what we call amino acid. Erepsin act on polypeptides and they give us what we call amino acid. Lipase act on fat and oil and they give us what we call fatty acid and glycerol. Maltase act on maltose. Maltase act on maltose and they give us glucose and another glucose. Recall at the onset of the class, I said that glucose plus glucose will give us what? Maltose. Glucose plus sucrose will give us what? Glucose plus fructose will give us sucrose, while glucose plus galactose will give us lactose. So when lactase acts on lactose, it will give us glucose and what? Galactose. When sucrase act on sucrose, it will give us glucose and fructose. Now, it is pertinent for you to know that before now, years back, a long time ago, enzymes are named by adding ASE to the substrate on which they act upon. By adding ASE to the substrate on which they act upon. For example, now the maltase act upon the maltose. So you just pick the malt there, then you add ASE. Whenever you see ASE, you will know it's actually what? The name of what? An enzyme. Like the proteases. Initially, the proteases, they are enzymes that act on proteins. However, but the names have actually been changed. It is not, before, enzymes are named based on the substrate they act upon, but now it is not like that. And that's how we have those groups of enzymes. And now they are named based on the reaction they carry out: hydrolysis, oxidoreductases, isomerases, transferases, ligases, and lyases. So I take it for the last time. Thiolin is found in the mouth, secreted by the salivary gland. It acts on starch and it digests starch partially to maltose. In the stomach, don't forget, we have the gastric gland, which is the source, and it secretes pepsin and renin. Renin act on milk, act on protein to give us curdling of milk, and pepsin act on protein to give us what we call peptones. To give us what we call peptones. And so coming down, we have the duodenum. Inside the duodenum, we have 3 notable enzymes, and these are secreted by the pancreas. Don't forget they are secreted by the pancreas. And what are these enzymes? We have the pancreatic lipase, we have the amylase, and we have the trypsin. The pancreatic lipase acts on fat and oil to give us fatty acid and glycerol. The amylase acts on starch to give us maltose. Trypsin acts on peptones, protein and peptones, to give us what? Peptones and what? Polypeptide. And lastly, in the duodenum, we have some groups of enzymes that are secreted by the succus entericus, and the groups of enzymes are called what? We have the erepsin. Erepsin acts on polypeptide to give us peptones. We have lipase. Lipase acts on fat and oil to give us fatty acid and glycerol. Maltase acts on maltose to give us glucose plus glucose. Sucrase acts on sucrose to give us glucose plus fructose. Lactase acts on lactose to give us glucose plus galactose. And as usual, some questions will pop up on your screen. Make sure you do the needful, try and attempt them. Should you be having problem with the topics and the various outlines that have been treated thus far, try and go through the video over and over again. It's been a nice time out with you. We've all had an academic adventure. Peace out.